Welcome to the 11th lecture on approximation algorithms. Today we will talk about the maximum satisfiability problem and how to solve it approximately very well using randomized rounding. Let's start with the problem definition. We are given a set of Boolean variables. We have n variables x1 to xn. Boolean variables can hold truth values, so they can only be 1, which means it is true, or 0, which means it is false. And then we have a set of clauses. We have m clauses, C1 to Cm, and each clause consists of some variables, either negated or unnegated. And we also have a weight for every clause. And now the task for us is we want to find a truth assignment to these n variables, such that the total weight of the satisfied clauses is maximized. To make sure that we know what all these definitions mean, we have a literal, that is a variable, or the negation of a variable. So for our Boolean variable x1, this could be either x1 or not x1. Then a clause is a disjunction of literals. So for every clause, we have some of these literals, so variables or negated variables, and we want that at least one of these literals is true. So this clause here reads x1 or not x2 or x3. So this clause is satisfied as long as at least x1 or x3 is true or x2 is false. And if one of these three holds, then this clause is satisfied and we can count its weight to the total weight of the solution. And the length of a clause is just the number of literals in it. So here this clause has length 3. Now this problem is an NP-hard problem. In particular, already the decision version is NP-hard, which is the satisfiability that most of you probably have heard of before. If we have a given propositional formula in conjunctive normal form, is it satisfiable? So is there a way that all the clauses are satisfied? For example, this one here. The conjunctive normal form means that we have a bunch of clauses that are conjugated with an and symbol. So this formula says in the first clause x1 or x3 has to be true or x2 has to be false. For the second, x2 or x4 has to be true or x3 has to be false. And for the fourth, x1 has to be true or x4 has to be false. And if at least one of them holds for all of the clauses, then this is satisfied. And the decision version of this works, that's already NP-hard. And here it's even more general, because even if there's no way to satisfy all of them, we can still try to maximize the total weight of all those that are satisfied. And that we want to try to approximate.